copy, new file. That's not how that works. Kaboom! As they say, they don't say that. Open that, open this. Make that a little bigger, even though I hate it. Oh yay. So, couple of things to work on here. If I go to the driver, so options colors is a pool. It's getting passed into here. Use color goes to here. This isn't passing up. This should use color. I think that's all I care about here. Cool. That should give me colors again. So we're going to be doing, in parallel, AST printing and parsing for a short while. Once I get comfortable with both sides, data structures and processes, I can start doing one more in bulk. We can design the entire syntax tree. Probably not, actually, because I'm trying to parse a bunch of erroneous cases as well, and then those will get transformed if necessary, depending on how much of SEMA we can expect to do. Right, so we still don't have color. I wonder why. Right, because C exists here. C use colors. And if we have reset, that's fine. What is name color? Name color is reset. That's why there's no colors. Base color and name color. Okay. So I should go ahead and create a fuck ton of new colors. I might want to override name color. Color, let's say, what kind of things are we printing? Let's say tree color. And tree color should probably be something that I guess that's what the base color is. And the base color here is white. I would prefer this to be anything but white. So, what color do we want the tree to be? I usually do red. I think I'd like to print the parse tree and the semantic tree in different colors. So maybe actually white being the default color is a good idea. And I can instead change the base color here and say base color equals color. For the syntax tree, let's do green. And instead of calling this module dump, no, that's fine. Module dump will be for syntax. I'll have another one for translation unit, and we can make that one. Expression must be a modifiable L value. That's right, because it's const. Static even. So I could override it, but it's being used here. So let me come over here then and say color, base color is color white, which can just be white. And then instead of being static, These can both just be const expert. If I make them const expert, actually, can I do it now? Because they're const expert, it shouldn't be changeable. It's not modifiable. Oh, it is. Oh, perfect. Then I don't have to do this. Learning semantics on the fly. So then this is color green. Do I need green? I don't, because it's being used by the parent. So base color is green. Name color can be reset. That's fine. So now, right, if I print header, hold on, AST Writer has this print basic node functionality, which prints a basic header, which does some stuff here. So if I come over to here and I print my header, we're printing a basic header. And a basic header is going to have a name, which is going to use name color. But I don't like name color being here, right? Because it's part of the tree to me. Name color. See, like, I don't like it being name. I like name being, hello, perfect, how you doing? It's very tiny. I cannot tell what that is, but it reminded me of Alistar. I don't think it is. Okie dokie. I'm obsessing over colors, which is great. I think most of what's in here should be using base color, and then I can say, like, location color. Could be magenta. Because then I want this location to be the location color. I want tree structure stuff to be in base color, which includes maybe, like, we have an attribute color. And that could be blue, could be yellow. We'll tweak the colors later. I just want to have the ability to do this. So the attribute color here could be that. So then the leading text of children is base color leading text. Then that's fine. I like all of this, because base text, base color, we definitely want the tree structures to be the base color. So this should give me some colors now, and then we're going to have to add some routines for collecting children. And part of me wants to be able to print tokens, which this is not currently going to support. So error, non-static data member cannot be const expert. Oh, static const expert is the only way to do that. So none of these get to be const expert. We're just going to override them at will. And if this runs, we should see a handful of colors and like 1% of a syntax tree. We'll work through some warnings as they show up. So in this case, type being unused, that's fine. We don't have anything doing types yet. Okay, so now our tree is in green, the location is in purple, and everything else so far is in white. So I'll probably have two things here. We can do value, and we can do keyword. Keywords could also probably do to be maybe blue, and values could be yellow. Maybe attributes can then be cyan. So then if I come back to my module dump here, we have, instead of a name, this can be a value color. And then as gets to instead be a keyword color, and then the name gets to be a name color, which is just white. And I don't really have to reset the color at the end all the time. I can either add the reset at the end, or we just assume that it's never reset, so we're always changing the color, but because I don't want to have to reset after every single line here. I don't need C reset here. I don't have it there at all. This, so then I can just say out plus equals this, and that's going to be std format, this C reset, just for shits and giggles. And we should have a handful extra colors without anything going wonky. If we do, we'll continue with children, I think. An error. Yellow is not spelled correctly in the writer. Yellow. Okay. Linking. Cool. Yellow values, blue keywords. That's a good enough start. Like I said, we can tweak those colors later, however we want. Let's do a couple more things here. I've got references over here that you can't see, but you'll see them as I copy them, so it's okay. When I'm printing children, what is that? Interesting. Lots of interesting. So in AST Writer, we have print children. Okay. We can print either an array, a vector, or a span with leading text and something to handle. So the leading text will default to nothing. It'll be an empty string in all cases, and then it gets appended with this stuff as we go down. So we need a function to collect all of the children. Which I don't think I have reference for. I do. And here's the thing. Type to print. We're going to end up calling operator call on ourselves. So I need to implement operator call first. We are going to do a thing. We're going to implement operator call down here. We are going to do this for a syntax node, E, which will become node. We print the header for node, which is our header. We print node children for node, and we move the leading text. Print node children does not exist yet. This is one thing we're going to be implementing. Here's the other thing. We really want, I think, to take a std variant, even though we don't like variants. It's either going to be a syntax token or a syntax node. Token or node. Right. So then we really want a syntax token. Token. And if we're printing a token, tokens have no children. Tokens have no children. For now, get rid of that. Instead of printing header for a node, we're just going to print token. Token. And this will be good for a couple of reasons. So above print header, we can just print, oh my god, print token. I don't know why I copied this, because we don't need that. I need to get my mic fixed. I keep seeing typing peaking my mic. So then using TK's syntax token kind, which I don't actually have to do. It wouldn't hurt, actually. So I've got in the driver this. But we're not going to do exactly this. So we're gonna reference this for the kind of information I want. But we're basically going to say print basic lie node. So node here prints a basic header. And a basic header has a location. So we're just going to copy this part into here and say out plus equals, instead of node name, this will be a, do I get the, print the kind2 string of token, and then token location position. Right? Then we're going to do a couple more things after that. That gives us that. So then I want the color, yep, using the thing that I'm familiar with. Value color, we're doing some printing. I want to also print tokens, so I'm modifying the other system to allow printing tokens, which currently means, and you're going to hate me, I'm going to try returning std variant for children of nodes, unless there's a modern C++ 23 and beyond feature that you would recommend instead, because I don't want to write my own trivial pair class right now. Which maybe I do. Maybe I do that. Maybe that's the answer. So for value, I then want the token spelling question mark. For at least the syntax tree, I'm trying to keep track of relevant tokens in as number token. I'm trying to keep track of tokens in just the syntax tree. The semantic tree won't have to deal with this, but I want to print either a token or a node so that tokens can be children of nodes. And I don't necessarily want to create whole heap allocated syntax node, which just contains a single token to get around the problem. So spelling needs to be in context. I don't have access to the context here. So the syntax writer needs the context. So we're going to take in context ref context. And that should solve that problem. So then the syntax writer needs context, which I think needs to be this. Oh, but not here. Nope, here. Like that. It's used for nothing yet, but when returning a list of children from a node, I'm going to construct a vector or an array or a whatever of variant of these things. So I just need either a child to be a token or a node. And this can also help me remove this mess from the driver. The driver doesn't really need to know how to print a token. I could still use the module class here to dump tokens instead. But that won't need the variant. I'm just going to be printing the tokens out of the module. So then I can check the kind, and depending on the kind, we could include the literal text here. Because this is how it appears in source. Spelling. But knowing it's parsed, I feel like I better do that with a visitor unless you actually need to store the variance somewhere. I don't need to store the variance somewhere, no, and you're probably right. Now that I have these two functions, I could just say, hey, for each child, do the child thing. So for now, let's not do that. I'll just have to change the way we handle children. Rather than collecting the children, we just pass a lambda of, I guess maybe not even that, just... We'll figure it out in a second. So spelling, and then in the driver, I've got just give me all of the goddamn for literal values. Including the text. The text is only relevant to some tokens, and for some tokens will be identical to the spelling. So let's switch on token kind. By default, do nothing at the very end, out plus equals standard format, new line with C reset just to make sure. So for identifiers, we already have the spelling, which is technically not always, but most of the time the same. But I should probably still do it. So if I say case, pk identifier, then how do we want to do this? For an identifier, the it's going to have name color for sure. And it's going to be the text for sure. Oi. So the question is, do I format it differently? Or better yet, do I include something like this for the spelling? Do I see reset, then value color, spelling, then reset again? And then I can say, hey, there's the token text for an identifier. If we're doing a string, and do I need the spelling anyway? The spelling is good for at a glance, but you can just look at it in the source. I'll leave it for now. If it gets messy, we'll pull the spelling out. For a literal string, instead of name color, we want value color. That's going to be token text as well. For a literal rune, if it's a literal rune, we do either of these two things. So instead of standard print line, we want out plus equals code point, or out plus equals and neither of these want that. This would want \u x code point, like that. Okay. Then for integers, we don't need the conditional, so we can do literal int. Literal int here does some things. So I want out plus equals this with no quotes, like that. And then floats are very similar, I believe. Float value instead of integer value, toString into the buffer, the same thing. Okay. And that should give me most of what I care about, plus a new line. Okally dokally. So now we need a way to print these tokens. I'm going to start by refactoring the driver here. So rather than this, rather than any of that, and I need to print the module header somewhere. I haven't done that yet, so I'll leave it here. For each token, I now need to go to module dump. I'll probably, instead of small vector char x, you can just do small string x, because where did I? Okay. 82 small string. Okie dokie. So I could probably just go ahead and say dump tokens and dump tree as two separate things here. If I go back to here and I say dump tokens, dump tree. Right. So then print this. Printing the entire module should give us, we can call this tree. Fuck it. And then dump tokens. This. So then for this, we want const auto token in module tokens. Print token. Or I guess, for shits and giggles, this token. How do we do? Is it like this token? That feels wrong. Is that what this shit is doing? If so, I don't like it. It's not really doing anything. That feels wrong. Printing top level node is no different than printing any other node, really, but so maybe this should also just be this node. And then a top level node is no different than a node. So then back in driver, we can just say for each module print dump tokens, options, colors, and module dump tree, which simplifies the run job a lot, assuming that any of this works. So if I come back over here and do lex, do we get a list of tokens, or did I fuck something up? Yes, I'm slowly fixing the warnings as I come across them, don't worry. Linking. So there's all the tokens. That needs a color reset around the delimiter here. So this just didn't actually show up? Question mark? Wait a second. Did that just not throw an error for having the wrong number of arguments? Or am I dumb? It's linking. What the heck? That's dumb. Okay, import. I don't like that they're the same color, so maybe it should be like the keyword color. Yep. Fun fact, the word localization. Come on. Why not? If I put it over on this screen, I can see it. What about this screen? There it is. Localization. Gets all highlighted. I don't like them both being yellow. So value color might want to be LMA. Oh. What other colors do I have at the moment? I could do the base color. That's kind of like base colory. Dude, my sinuses are fucking me up. Okay, so that'll do that. Then go back to parse. Okay, so there's what little we've parsed, or what, yeah, both what little we've parsed and what little we've printed of the current syntax tree with invalid nodes, which are these two. Okay, so now we need to print their children. So originally, we had something to collect all of the children, and then we printed them all in sequence. What we actually want to do, though, is not that. We instead would like to, if I just call print node children, this doesn't exist. But what is it supposed to do? Takes the leading text, passes it along. So I could, for example, just say print node children const syntax node string leading text, which has been moved in here. Now it exists. I can just switch on node kind. Interesting. Okay, so all I need to do, in the default case, no children, easy enough. Then let's start. We can pretty easily test with case. I have K up here. Saray will love me for this. I don't need colors, I don't think. Whoa! Case K import invalid we'll do first. So here we want to, I hate this, but probably what we want is, I need to auto n equals as syntax invalid this of node, then print n token import and leading text. Like, this will be ugly as hell. But what is type type? What do you mean type type? This? I don't know why they're renamed here, but it's the type of a type, which in syntax we don't have. Syntax has no types right now, so I'm just passing null pointer, and also there's no string on anything I'm passing in here, so this will probably have to change slightly, or I'll have to give it something that has type string. But okay, so let's just we have token import. Oh, actually, we for const auto ref maybe tokens in n token consumed tokens, which I think we can do just fine. Token semi if it exists. Okally dokally. Let's just see what that looks like. Because I feel like it's going to look wrong. I don't think this routine is prepared to print the tree structure, so it's going to just be a flat that we have to fix, which is going to be annoying. Yeah, so import invalid has import and semicolon, import open close semicolon, boom. That's all the tokens, that's great. But since we're doing it this way, we don't have, like, we need to transform the leading text. This might be where we want to, at this point I just call the function print instead of overload call operators, because this is pretty horrible. I mean, yes, I just don't have variants of this. I don't like this, trust me, I hate this. So if I instead do print, and then have this just call print node leading text, that's what I would like. I just didn't have that before. So we're not printing the leading text anywhere. Am I passing what to visit? I don't have a visitor yet. Maybe. I don't know why I have the call operator here, honestly. I think this calls things sometimes if I'm printing children from it, because print children is what's taking these spans, which is why I wanted to use like a variant and just copy this. But this is really the only reason to have the operator overloaded, because it does this, but it's not even using the operator, it's just calling operator blah blah blah. So this is responsible for handling my this stuff, which I want to grab right now. And this is where I was going to generate a vector of variance, call this on the variant, and have an operator overload. I haven't copied it from yours. I copied it from LCC way back when. So I can, if source has a newer one, I'll do that. I just don't have source open right now. That is why it's jank. What is yours? Is it an AST printer? You have a printer base? Where is printer base? Is that in core? Printer.ccm. I didn't even see that. So fuck it. Interesting. I should just, hold on, close everything. Too many things open. So it still takes an array. It is much simpler, so I don't hate it. Let me go. Fucking yoink. I have done the unthinkable, and I have removed the U in color from all of your things, by the way. We're going to call it. I'm using it for a couple of things, and we're writing to a thing. I don't want to stud print. I guess I could just do the stud print, so. Then I can rename this to tree printer. ADT small string, print. Okay, so then in module dump, I need tree printer. So then we don't need this, we just need syntax node, and that's a front tree printer base. So then tree printer base probably should use color. If it doesn't, does it use color? Cool, good. Get our color. I want all of my colors back. So no. I don't want to rename it, but I want it back. Hold on. I'll just getting notifications. All right, no dinner tonight. I wish I could undo the text, but not undo the rename, right? If I hit here, fuck it, we'll rename. Because I just want to copy all of this so that I can use it. And then I want to redo that. Cool. Cool. I don't think I put mine in utils. I don't think that exists. I think it's just colors. All right. Let's see. The type identity nonsense is to inhibit typed template deduction. You'll probably have to merge the two implementations, but this is the same implementation. Right, but I'm still going to have to collect not into a node pointer, but into like if I want to also print syntax tokens, this is where I'd be using variant. Right, so if this is doing the managing of whatever, shouldn't be undefined, I just defined it. Okay, so, right, if I'm doing this, I just have to implement print for whatever I'm calling on a child. So let's just, all of this, to make my life easy, fuck it, doesn't exist. No longer exists. We are going to do both of these. Instead of saying dump, now that we're doing printing, let's just say print. I don't know why I like the word dump. It sounds stupid. Print tokens and print tree. Print tokens, const syntax module. You can maybe use LLVM pointer union instead of a variant. Yeah, but I don't have pointers to the tokens. I guess I can take reference to them. That'd be fine. So, print tokens, syntax module tokens, just for const auto ref token module tokens, print token. So then I'll need a print there. Then if I print tree, we can just say nodes. What was I going through before? Top level declarations. That's what it is. Print top level node. So then I need 3 instances of print. We need a void, print. Yeah, print needs a. I'll have to print the token by pointer here to make this work. So const syntax token, and print needs leading text. Print, no, the leading text is happening here. So we just print. Then we need to print syntax node, and then we need to print some kind of pair. So you said LLVM pointer union of syntax token, syntax node pair. I think I saw this in their documentation somewhere, and I want to, and it's, is it in this one? Or is it in support? It's in this one. Okay. So then, if pair dot something dynamic cast get is. I think I want is. Hold on, adjusting. So is, I assume that's templated type name, so syntax token, like that. Now does get, if I were to use get, can I do that? If auto get whatever, inline get. If, okay, so I can't call get because it's going to throw. Yeah, okay, dynamic cast. So if auto pair din, if auto token equals pair dynamic cast this, then print token. But this needs to not be, must have. So this is returning a pointer though. It's not returning a pointer. So do I have to do this? If I can hit the right button, like that. I figured since they're both pointers, it would do that for me. Else print pair cast syntax node get, not cast. Do that. So then something I'll probably do here in syntax node is do children here. If I just say straight up children, and instead of doing this variant, we decided LVM pointer union syntax node syntax token. Well, a token is not pointer like, so that's not going to happen. Const is fine, so this will need to not void auto. If I want this to be const, do I just need a const pointer union, or do I also have to like const syntax token and const? Like, do I have to const everything to make this const? This. Okay, but I don't have to const everything inside. What's a cursed approach? Well, right, but then what do I do? Yeah, I'm not storing these anywhere, so you're right, that's not going to work. But if I'm passing them to print context, they have to live somewhere. Or not print context, print children. So, return a vector and make it a coroutine. I don't know how coroutines work, so tell me how to make it a coroutine. I'm fine with a coroutine, I just need to know what to do. C++ coroutines. Generator task. Lazy. Do we want a generator? Off to the Discord. Ow. So do I want generator? Okay, so we want a std generator of thing. And I need to include that from somewhere, I assume. Coroutine. Does that give me what I want? And not in coroutine? Nope, that's not what I want. Is it std generator? Does generator work? Coroutine exists, maybe. Where does generator come from? You gotta include the headers, Sarade. I don't know what they are. Let's see. The header is generator. Okay. Why doesn't it show up? Why is there no generator? All that work. I mean, we can try compiling it, and we can see if it's just a IntelliSense error. Well, that's stupid. Then we can't use it. Looks like we're returning a vector. So if I'm returning a vector, now do these have to be const? God damn it. Why can't compilers just actually support things? Oh wait, because C++ is stupid. So yeah, where the hell does const go if I want this to be const? I can see that reconnected Are we back forever? Can I keep my internet, please? Please and thank you. Fuck it, we're just doing a vector. We're just doing a vector. That's all we're doing. Now, do I care to make this virtual, or do I just want to switch case everything? I think we just want to switch case everything. So let's go add a new, I think back. It looks pretty stable. So syntax children cc. Using namespace choir and using namespace choir layer, to include choir core and include choir from layer, auto syntax node children const whatever. Declaration is incompatible. Reconnection successful. We're dropping all kinds of reconnection successful. Wow. Yeah, no, I wouldn't be surprised if it's my ISP. ISPs suck here. Could also be the router. Could be the network that I'm on because I'm in an apartment building. Maybe somebody's downloading massive terabytes of child porn or something. Maybe I shouldn't say that on YouTube. Maybe I'm going to get banned for saying that on YouTube. Oh no. There was a pedophile arrested a couple years ago, so I'm not joking. 2 hallways down from here. When I looked out my window one day, there were just a fuck ton of police vehicles, and apparently they arrested a child predator. Don't know why you'd need that many vehicles for that, but you know, you gotta have something to do. Anywho, we want to collect a std vector of all this. Why is it saying error type? Because I missed this, that's why. If I just scroll to the right, okie dokie, switch on kind. Default, do nothing. There's nothing to return. In our case, let's say case k import invalid. We can then say children push back. Now, do I have to constructor this any specific way, or can I just give it one of the two types? Null pointer t, pointer u, whatever. Get is whatever cool get. Operator equals of null pointer. Get opaque. Yeah, how do I make this? It's a pointer union t-tail pointer, just give it the value. Okie dokie. Auto n equals as, I guess I could do cast, just a hard fuck it. That's a syntax import invalid of this. And then I can say n token import, which needs to be a reference to n token import. Very strange. Like, how does this work? Does this work? This feels wrong, because I'm returning by value. So where the hell does this live? We're returning the value. This is getting copied. Unless it's not getting copied and there's a hidden elision of the copy, and I've got, but it's a value. I'm not returning a pointer or a reference. I could return a pointer or a reference. I feel like I shouldn't, but I could. Should this return const syntax token reference? Can I take a reference to a reference to get the pointer? Well, auto never deduces a reference, sure. This is... Okay, so does it not like that it's const? Or does it not like, because it's a syntax token pointer looks correct. Well, it's a const reference now, yeah. So this is why I wanted this to be const. Can I do this? Because you said don't make it const, but I want it to be const. Now that works. I'm still not even sure if that's the correct location for const for what I want. But that's what we're going for. Maybe. Now, new problem. Consume tokens is also doing by value. So this really should be reference question mark? Can I even do that? Can't. Can I? Can I? That fixes this. If I can do this, then that works. Can I take a stood vector of values and return a span of references? That doesn't make any sense. But then, like, what do I do? You see my problem? Do you see? Do you understand why I didn't want this to be a pointer? This doesn't make any sense. This is not allocated anywhere. I just wanted to use a variant. Well, I mean, I am returning a span of tokens, but that token has to live somewhere for me to get a pointer to it. We're talking about pointers. How do I get a pointer to the token if it's going to die after this function leaves? Yeah, that's what I've got. That's what I originally had. It's a span of syntax tokens. How do I get pointers to these tokens that live longer than this function? So I can do this. I can do this line 19. I can push back a reference to a reference of... Because the span doesn't know the memory. It's giving me just this. If I'm iterating the span, I can get the address of whatever. So I have the address of whatever's being referenced by the span, which lives in the vector. So it's not being copied, is my understanding now. So this will work. I can get a reference to the reference to the reference to the, all the way up to consume tokens. So I can do this. Okay. Why C++ gotta be complicated? Where am I gonna put this? So RAID wants that to be a type union, type using type alias. So I don't fucking know. Way the hell up here. Using syntax token or node pointer equals that. And we don't want the vector part. Okay. That. Then this. Is that what we want? Does that work? Do I win? Did I do it? Okay, now I need to print actual things again. So printing, I deleted my printer stuff, of course, so I can ye old undo. Go all the way back. Right before we delete everything, put it all back. So put it all back. Does it work? Okay, so then way up, don't need this anymore, way up here. Let's start with tokens. We can do tokens. So to print a token, we just want to stood print something, right? That's all we're doing, stood print. So if I do this, and instead of out plus equals, I just say stood print to get all this stuff back. If I using color question mark, And then everywhere that we have token dot, we use token arrow. Using quire color. Question mark. Is color not? Can you not do that? Didn't I just do that? Do I have to do that here? Using enum, okay. Enum. I thought I had done that before and it worked, but there we go. So now I can print tokens. If I just do this with Lex. Oh my god, my head. If I attempt to Lex and print tokens. Okay, what are we missing? Use of undeclared identifier array ref. Okie dokie. Did I? Okay. Tree printer. So we're missing array ref, right? What about now? I assume it's an ADT. I didn't even check. We'll go through the warnings. What now? Because it's LLVM array ref. This is an LLVM string ref. You know what? Fuck it. Using LLVM array ref and the string ref. Using declaration in class refers to LLVM, which is not a class. So I don't do that. So then I want using array ref equals. Can I do that with small string without templating it? Do I have to template the using to get small string? Fuck it. This is why we do things the hard way. No. Utils doesn't exist. It's using enum. Quire color, just in case that matters. Small string, string ref. Build. Oh, I missed one. Oi, build stop. 2 errors. Parameter node. That's a warning. Implicit instantiation of undefined template. First index of type. Oh boy. What is this in? This is in K. This is coming from pointer union. This is coming from. So what's my problem? Lots of notes, lots of notes, lots of notes. Still going. Dynamic cast. An instantiation of function template specialized on whatever. Const. Oh, because I added the const. Okay. Do it again. Linking. Oh, I didn't include a new line. C reset. No new line yet because now I need to do all this shit. Yep. Okay, but it is working, kind of. So everywhere that we have stood format, out plus equals stood format is going to get changed to just stood print. And then everywhere that we have token dot becomes token arrow. And we do it again. Do. I know I get frustrated at this shit, but I appreciate the help. There's just so much unknown. So much unknown. Linking. Gotta be copying. There's the tokens. Cool. Now, notably, these tokens will change after parse. This won't be an identifier, it'll be a keyword. But we can't see that without parsing. So we can go try parsing now and printing the nodes here. So to print a node, I can print a header, I guess. We can keep print header, maybe, question mark, doesn't really matter. If print node is always going to print children, then we can just yoink all this. We're already using color. So then print basic header is doing all the heavy lifting for us. Or basic lie-in node is also doing a lot of the heavy lifting for us. I think this is just calling print header. It's calling print basic node. Let me go copy this from the other place then and we'll get it working. Not from source, from this. So here, print basic node. Print basic node prints the header, and that's it. We don't have a type right now, so void print header, const syntax node, which, I mean, for symmetry, I can probably do this part as the header of a token. And then we have all the specializations in here, right? So then printing the header of a node is going to be this. Standard format. So I not have access to C. I do, it's right there. Name color is right there. What is it? Oh, because spelling. So then the node name is I guess we get that from its type. I don't think I have a toString for that yet. So printing a header here, I need to have its name, or go ahead and do a syntax node kind to string like I did for tokens. So syntax node kind to string node kind. And just put that in syntax here. I have syntax token kind to string, syntax nodes kind to string. Now token did regular string. Yes. So then I can just switch kind default unknown. What did I do up here? I want to return the same fucking thing. 2 question marks? I'm so predictable. So then for right now, we can just yoink, paste, get the last, copy, case, k, sure, return this, k. So then using k syntax, just kind, which actually means that this is kind of useful or useless. So at the moment, that's what we've got. Module dump, which I'll rename later. So then when we print a node here, we're going to print header for the node, and then by default do nothing instead. So we don't have to print a header for anything here. We don't need new lines, we're doing new lines later. So here, already printed the header, stood print, stood print this, so then this is print, come on, that. Both of those will be a second here. None of these need explicitly the new line anymore. We're going to print this plus a new line. Okay. And then print children of, it's deducing this, and then I need to say node children. Stood move? Do I need to move, or because it's a parameter, is the move implicit? That is more semantics. You can check the new project for some examples. So just combine print header and print node children into one function nowadays. Interesting. You can check the new project here. Okay. AST. Oh, because you take print extra data. Don't move that, yeah. For right now, to keep it simple, we're just going to do this. So then print children, no instance of function, whatever. Okay. Okay, let me read. So the node is type, so I need to give it a new node type, basically, which is, but it should be like, do I have to? Do I have to say that this is the whatever the fuck I called it? This explicitly? Because, I mean, argument types are just that. Template class node equals whatever, but I'm trying to overload the node. I don't want it to take it a node. There's a better way of doing that. Right. Okay, yeah, we're the only two chatting. We may as well. Fuck it. Plug in. Share my screen. Don't share system audio because they're going to hear system audio anyway. Or you are, it doesn't matter. All right, I'm in voice. Hello.
Thought this would be easier than to try and explain all of that via text with however much lag there is.
Enough.
So, a few things. First of all, go back to print children. The only reason that template parameter exists is if you have, you basically don't need it at all. You can just remove that, not make it a template, and just pass in an LVM array ref of your pointer union.
But I want to use this. I want to use this for more than one tree structure.
In that case, just remove the node star, the pointer there. That should do it. Yeah, make that node instead of node star.
Okay, that makes sense. I forgot it was taking the pointer. I commented on that when I copied.
The only reason why that you don't need the template parameter now. The only reason why that exists is, say it takes a vector of, like, say that the type is like, I don't know, statement, and you have a vector of statement pointers in most cases that you want to print. But then you may also have a vector of, instead of statement, I don't know, if statement, and you don't want to allocate, but you can't pass a vector of if statement or an array ref of if statement if the function accepts an array ref of statement. So in order to avoid allocating a separate vector, you can pass it a template parameter to tell it, hey, instead of taking a vector of or an array ref of statement, I want you to take an array ref of if statement, so I don't have to create a separate vector. That is what that template parameter is for. It's used rarely if you already have a vector of some derived class for some reason, which you're not going to have here, so you can even remove it entirely if you want, but just making the default parameter just removing node star and the star there works, because by default I don't have pointer unions anywhere, so I just don't want to write the asterisk everywhere.
Yeah, no, I'm probably going to want that asterisk there because, like, the semantic tree, definitely all of them are going to be pointers. I'm not going to be doing the union nonsense, but the syntactic tree, I want to print tokens.
That was that.
What did we do here? What did I miss?
Another thing is the using thing you tried earlier. That has to be a namespace scope.
So yeah, I saw. I just didn't want to do it there.
I would just put that in your core.hh header inside your namespace, and then you just have that everywhere.
Which is why I haven't done it, because I didn't want to put it in that file.
Using span of const somewhere, in a few cases, you can also choose array ref, because array ref implicitly makes its elements const.
Okay.
If you want to mutate it, you need mutable array ref instead. So array ref is const by default.
That's
and
good.
It has a few functions that are nicer than span, like I can take the first 3 elements, drop the last one, wherever. Span doesn't have that.
That might be nice, yep.
So, I generally recommend using array ref because it's just a better class. That was another thing. And, oh yeah, instead of using a vector, I'd use a small vector because then you can probably avoid heap allocations in most cases.
Right, yeah, I can change that in a second.
Because the pointer union is pointer sized, so...
Yeah, so this is...
Well, token semi returns more value, apparently.
Yep, hold on, let's go. Yep, we didn't do this to this one. Moving a local object in return statement prevents copy illusion. Okay, so I don't need it there either.
No. Yeah, don't do that. Typically, you don't, if you can avoid it, you don't want to return standard move. Because the way this works here is, the reason why you don't want to move here is, what the compiler will do is, it will allocate the memory for the return value in the caller, pass an implicit pointer to it, and then this local variable that you create here will actually be in the caller. So it doesn't return anything, actually. It just builds the vector where it's supposed to go, and then just starts inserting there in this function. So there's no moving or copying happening. It just constructs it where it's supposed to go. That's what is typically done when you return a class by value from a function. Unless there's some control flow involved that makes it so the compiler can't deduce which thing is going to be returned. But as soon as you only return one thing, it's pretty clear usually.
Well, I've done something wrong. That's about half correct. Module dump. What have we done wrong? Print header probably is doing something wrong. It's just calling std format.
That's classic. Just format it into the void. I wonder why format isn't no discard. It should be no discard.
Probably should be.
Maybe you just ignored the warning or something.
Maybe. No discard being a warning, not very no discard.
I mean, you can make an error, but
yeah,
no, it's a bit obnoxious.
Okie dokie.
Coloring isn't quite right, but
yeah, I don't think I space up because I copied over base color. No, base color should be green for printing the header here. See base color, but that's for the token. I didn't do that for name color here. This should be base color, and this should be location color because I copied from the wrong source. That should fix all the coloring. Ink faster. Okay, there we go. Now this should probably not be red. This should be whatever my base color is, but that's fine.
Yeah, that's probably true. I use red, but that's what's red.
I want to do red for sema and green for syntax, so I'm changing base color based on that. So instead of C red, that'll be base color for both of those. That way I know which tree I'm printing at a glance, even though they'll look very different.
By the way, in case you're curious about that type identity thing, if you go back to the print header thing real quick, so the only reason why that is there is because because of this template here. If you just do LVM array ref of node, it will then try to deduce node from the parameter. But if it needs to construct an array ref of that, there is no way for it to deduce array ref of node when it has a vector of something. Like deduction isn't that advanced that it would consider possible constructors or whatever. So it just fails to deduce. Even though you've specified a default value, it will still try to deduce it. And if it fails, you have a problem. So type identity here tells it, don't try to deduce it. That's all it does. It takes a type and returns the same type, but the way it's implemented inhibits template deduction. So that's a trick you see sometimes if you have a parameter that you don't want to be deduced.
Right. So if I wanted to do the semantic tree one, I just have to set node type to be a pointer to, not just... Okay, so that's the only thing I have to do here differently. Because right now, I've got it set to be a printer of our pair. So then the sema would just be sema node pointer.
Yeah.
Everywhere. Cool. Cool. So I'll do a bit more of that. I haven't gotten anywhere near parsing done. How long of it? Almost 2 hours. Woo! Just to add and refactor and re-add printing. Okay. Okie dokie. Keep that open, actually. Move it to this screen like it's supposed to be. So...
Oh, by the way, because I see you using like as there in a few places.
This should be
probably that from LCC too.
Yeah. I think I saw
You can-
you had a new one, but I don't remember.
So I don't have a new one, but because you're using LVM, you can just use LVM's cast functions.
That's probably, yeah.
That's what I use.
I mean,
I
I've
would
already
also
got them.
what I would also do for that is I would take all the things that are commonly used, like small vector, array ref, small string, and also cast, diagnostic, and isa, and just do a using and put those in like some header that you include everywhere.
Maybe.
You're going to be using those a lot. Yeah, just keep in mind that the naming is a bit different between what we use in LCC and between LVM.
Mhm.
In LVM, cast will assert that it's that type. Diagnostic will return null if it fails, and is how you. It's not just it's is how you check if it is a type.
Yeah. I mean, I've already got it. I don't have to use everything LLVM. I might make the change eventually. I don't know, but like, yeah.
Yeah, I'm just saying my implementation is probably not as good as the one that we use in LVM.
All right, I might do that as well. I just don't want to do a whole bunch of refactoring all the time. I'll refactor all at once, not little bits at a time. So I just want to go parse something, and now I'm too tired to parse anything because I've done all this printing stuff. I saw you had a result type. I wanted to figure out a result system that didn't have to do with LCC's concept of diagnostics we were doing, right? Because that result was...
The best example of that is if you pull up my libbase, because that's what that is now.
Okay.
Take a look at that.
I might have that in the dependencies. Not
That
really.
also uses it like consistently. So.
Yeah.
But that
I don't think
is
it can
module
figure.
based now, so you won't be able to use it directly.
Yeah, I don't think I have it in VS Code because it never built properly. So let me go see if I've still got that somewhere. F checks. So go repos. This one.
Yeah, I can explain a few things about that real quick. It's we probably want the module, so it's probably in lib. There. So okay, of course it doesn't stand CCM because GitHub is dumb. But it's basically a thin wrapper on standard expected, which I do hope MSVC supports. Let me check if MSVC supports that because I don't trust that damn standard library anymore. I think they've been falling behind a bit with implementing features. They do have expected, so that's a start. So it would be easy to view this with syntax highlighting, but if you don't care about that, if you go down a bit further,
I can just.
yeah,
this will give it some highlighting.
Some highlighting, that's good enough. So the main thing is if you go down a bit, up a
We're at
bit,
the
yeah,
bottom,
no,
yeah.
I meant up, I just can't talk. That's the main type. It's just a result impl is basically, so what this does is, you might want to write result of something reference, but that doesn't work well by default. So I have a few things in here that just convert reference to standard reference wrapper so that I can actually store a reference. So that means you can, unlike with usual container types, you can write result of like int reference, something like that if you want to.
Interesting.
That's what that reference wrapper store. Oh yeah, that's right. I'm not using standard reference wrapper because that one sucks. So I'm using this here. That is implicitly convertible to the actual reference type. It's just that you will, if you declare a variable, you'll actually have to write out the type or do at least do auto ref. I think if you just do auto, it will give you a reference wrapper, which is probably not what you want. But yeah, that's that. And if you go down further, what I'm using as the error type is basically just a string, like all the way to the bottom. And this is a function that creates when you can also call this something else because error is probably already going to be used. And the main thing to keep in mind is that the way standard expected works is because it's theoretically possible to use the same type for both the value and the error. So how do you know whether you're constructing a value or an error? Well, you wrap the error in standard unexpected.
Okay.
You probably don't want to write standard unexpected of your error everywhere. So this function just does that for you. It just takes it, formats something, and wraps it in standard unexpected and returns it. So you can just write, I don't know, return error or something.
Okay. If I
That's
just yoink, how many things from utils does this actually use that I have to resolve?
Don't think too much. We'll see.
If it doesn't really depend on anything, I'll put it in its own header. Like,
Mm-hmm.
And we'll get the imports and stuff in a second in the include guard.
One thing you'll probably not be able to use, unfortunately, is that said, MSVC has experimental support for statement expressions. So you can try turning that on. Let me check what the flag for that was.
This looks like it just works, so I should be able to go into core and just include it. Acquire core result. Okay. And then for my sanity, I will probably go into there, and instead of saying error, I will say result.
Check this real quick. Was it including was somewhere? Oh my god, in C. Okay.
Right, so I want to call this instead.
What was that?
Which then means I don't need that either. Configure. Old reparse.
That. So if I first have done that on and
What did I break this time?
okay, it doesn't like that apparently. That's interesting. Does this still work? What was I doing wrong? Oh yeah, that. Interesting, that's cursed. Oh god. So apparently MSVC does have experimental support for statement expressions, but only in C mode, not in C++ mode. The main reason why you'd care is because I have a try macro that you could theoretically use, but that won't work with MSVC, so...
Throw her.
You can just assert or something. Or wait, yeah. or fatal or whatever. That's basically you are trying to access a value, but this stores an error, so it should just scream at you.
And then error is a string question mark. It doesn't.
It actually just issues the error. Yeah, you should probably, because that probably takes a format string.
Yeah.
Yeah, so you'll have to do the thing.
That?
Yeah. The reason why throw or bot exists is so I can actually throw when I'm using I'm running tests, so I can catch the assertion and check that it's being issued.
Interesting.
That is fascinating.
What did we do there?
I think that is Windows nonsense.
Oh, yeah, that's
you
fine.
might have to do something to set up the
Yeah. Invalid use of base color.
Mm-hmm.
Okay, well that's in printer HH. We didn't really change anything here, though. At least we shouldn't have. Base color is a color. C should take a color. So... what happened?
What is on about? Invalid use of... Oh, you're accessing a member. You can't do that in an explicit object member function. You have to do this dot, because that's what the explicit object
yep.
is called. Explicit object parameter, yep.
Forgot we changed. That was a recent change. And we're back. Woo. Okay.
Is the reason why you're storing entire tokens in your SD nodes, or?
In case. Because it's not the full semantic tree, I'm just doing the parse first and transforming. And figured why not give it a shot. It might be good for semantic highlighting tools, or like at least syntactic highlighting tools, to get a somewhat valid parse tree before Sema is run to do simple analysis on. And while I don't necessarily need the whole tree to do that, I guess, necessarily need to have the tokens to do that either. Maybe somebody wants to traverse the tree and get the tokens, I don't know. For most nodes, it's not hard to do. Most nodes are just going to be nodes of nodes of nodes. It's only the leafs that need this. And if I go into my AST syntax, like, all I'm doing for an import here is I can give it the tokens rather than pulling data out of the tokens. And like if I want the text to the path, it's just path.text, sure. So I can do all of the actual accessing here anyway. It's not a huge problem. So for now, it's not a pain, and I like having access to the tokens just in case. For, like I said, maybe somebody will want them later. Maybe that somebody will be me. The tokens will be gone by the time we get to the semantic tree.
Sure. One
Probably.
thing I'm wondering is, how are you allocating the token? I mean, here they're just copy per value, sure.
Yeah.
Are you lexing everything before you pass, or?
They're all just going into a vector, yeah.
Because what you could do is just store pointers to the tokens instead.
That's true, that's true.
because you're just copying a lot of tokens around here. And the token is how big?
Sizable. It's got a few things in it. It's got all that junk. So yeah, we can do.
So that is
That's
you
big.
did a small vector of 0. Okay, so that's
Yeah.
fine.
So these are fine.
This is probably around. So this is at least 60. It's probably around 100 bytes.
Yeah. So we can change these to pointers. I'm totally okay with that.
Because not only would they be smaller, but you're also copying a lot of stuff around, because these things are not trivial to copy over the vectors, and APNt is also not trivial to copy because it may store more than if you have a number that's more than 64 bits, because APNt can just handle that. If you can give it an arbitrarily large number, they can pass it. I wouldn't try doing division on it, but you can pass it.
So then in this case, I can just leave these as pointers. Should be fine.
Yeah, that would mean you'd have to replace those with pointers everywhere.
Yep. That's what we're doing. So token import location means I don't have to determine the location at the call site either. I can just say, look, I'm grabbing the location here. I get to make sure I'm constructing the nodes with a valid token to like sanity check myself, because you know I like doing that.
You then just need to make sure that the tokens live long enough. So
Yeah,
you can probably
these are
delete them when you're done with Sema, but not before that.
Yeah, they live as long as the tree does, basically, because they're both in the module. When we destroy the module, we'll destroy the vector for both.
Yeah, because having few JST nodes is a bit not ideal. Let's put it that way. At least in Clang, we try to reduce on the usage of AST nodes.
Yep.
Quite a bit, because otherwise, you might run out of memory with just large programs.
Yep. Okay. That's one too far, but it's fine. I'll just remove this one. Okay, what's going on up here? Consumed tokens. Const pointer question mark. Okay. Then
Okay, that is a bit weird that you have to do that. Like span of const pointers is a bit of a strange thing to do. But
I mean, I might eventually change this to an array ref, and I might not need this, but not right now. Not right now. Focus on one thing. Now I got to go to parser to make all those updates, and then go to children to make all those updates. So in the parser, token then is currently returning a reference. This is copying it. So I could just, does that make it a pointer? It does. So I could do that, or I can make token just return a pointer by default, because it's going to be doing dereferencing anyway. So if I return the pointer, return that, then everywhere that we do this, we know how to do that. Then peak can do the same thing. Return that. Okay, that's a lot of everywhere that I use token dot. Token arrow. Okay, then push back into, this needs to be star. pointer. That's a pointer. Invalid location. Location is this. So then here, I guess I return now a new token. Problem, that's not going to get deleted, so that has to be put somewhere. I don't want to put it. Yeah, what do I do about that?
So I mean, this is kind of a weird thing to do, in my opinion, because if you expect an identifier and you don't get one, then I would not even build the node. Like, I'm not sure if there's much value in keeping around detailed information on nodes that have errors. I would just create one invalid token and just always return that or something. Like, I don't think.
Yeah, I don't specifically need the location information, but if I'm going for the every syntax node has all of its relevant tokens from the source file, then it feels
Yeah, but if the
weird.
node is not even well formed, then I don't think that makes sense. Like, if a user hands you random garbage, they can't expect you to create a valid AST node from it with all the location information of every last token that isn't even supposed to be there.
Well, right, but if I'm only looking for one specific token in one specific spot, I'm not looking for every single invalid token here.
Yeah,
In this
but
case,
still.
this is a very specific thing. I'm only ever using it in very specific locations. If I want to know where an identifier is missing, maybe this token helps me with that. I don't know.
I would just issue the error here and move on. I don't think you'll later ever want to revisit locations where an identifier was expected but ended up being missing that you have already diagnosed. I just don't see the use case for this at all. You need it when you issue the diagnostic, but never again after that.
See, because I still don't know what I'm going to want if I'm writing tools with this. That's my big question mark. I've never written a language tool.
What I mean, Clang doesn't do this. I can tell you that much.
Yeah. But I don't know what I'm doing that I can use instead.
I can't think of a situation where you would ever want to know about invalid tokens. Like, what is any tool supposed to do with an invalid AST node?
I don't know. Fix it. Control dot.
No,
fix it.
That's for the compiler to suggest. Then, if it issues diagnostics.
Yeah, but if there's like refactoring tools. Could a refactoring tool not use the information? I don't know where else I'm putting it.
If you want a tool that automatically fixes compiler errors, they can just capture the diagnostics because those will contain these sorts of errors anyway.
Yeah, well, I don't necessarily want one that says fix compiler errors, but if it's a well-known thing, like, hey, you're missing an identifier here, would you like me to prompt you for a name or something? I don't know.
I mean, if it's a missing identifier, then that's typically a situation where you want to declare something new, at which point no amount of autocomplete is probably going to be too helpful because you're going to be entering a new name anyway.
Right, but I mean, there's other situations. This isn't the only situation. Maybe it's import something, and I'd like to list all of the available files or modules that are in my thing, and I expected an identifier, and I'd like to be prompted for it, and I don't know what to do there. So I could go through a little tab list of, okay, I want that one, hit enter, and it populates. Like, I don't know how to write tools that do that, but currently I'm not storing any information that tells you anything relevant about this if it's not in a token. So I don't know what else to do. I get that the syntax tree is not the best place to put this, but I'm not putting it anywhere else either. Because I don't know what to do.
I'd probably say it's better to cross that bridge when you get to it and just not worry about that for now.
I mean, probably. But if it requires me refactoring the entire parser when I get there, then that's kind of a pain in the ass. It probably still will because I'm doing things speculatively, not knowing what they are, but I don't know.
Yeah, if you want code completion, you'll probably have to. The only way I know to do it is how Clang does it, where you check at specific points. Hey, like if you're after an import token, and code completion was requested at that point, you can say, hey, now I list all the module names. But I don't really see a situation where after you're done parsing, you would then go back to the tree and check for all places where some token was expected but not found, and then do anything useful with that.
I don't know either. Alright, let's just say that.
This just looks like, because currently this just is making your life harder with currently no benefit.
It's not a function, is it? Okay, it's just an arrow. Something like that. It's not really constant on that. To get around it for now, I might change how that works, but this will do that. Don't need the arrow. Okay. That. Because it shouldn't be const. That's good. Then. That. Okay, now what else am I missing? Probably the children. It's updated. Yeah, so let me just kill that. So this can then be syntax token or node pointer. Then this needs this. This will already be a pointer. Just do that.
Also, because I mentioned refactoring, at this point I'm somewhat convinced that compiler development is just 80% refactoring.
I mean, it is, yeah.
Uh,
So, warning, warning, warning. Again, I'll
because it
fix
feels
all
like
those.
everything I do in Clang ends with me having to refactor something. It's horrible.
No matching member function pushback. Parser 216. Because result tokens needs to be a pointer.
Mm-hmm.
I need to probably remove stead move from
Oh,
all
don't
of
do
those.
don't move a vector when you run it.
Ideally, I'm not doing that anywhere else.
Again, because the only thing standard move does that it forces a move, whereas by default you get neither a copy nor a move. It just constructs it right where it's supposed to be. So yeah, when you're returning a local variable, I think you should pretty much never move it. I don't think there's ever a reason to do that. If you're returning a struct field or a reference from returned from somewhere else, that's a different matter. But if it's a local variable, pretty much never.
The other reason for keeping the tokens around is so the parser doesn't have to figure out what trivia is important if I'm doing trivia. If I'm just going to end up discarding trivia and saying fuck tools, then this is irrelevant. But if I also just throw all the tokens that are relevant in here, then any tool that comes by, like a documentation generator, can look at all the tokens and construct any relevant documentation from whatever it thinks is relevant.
A documentation generator won't be able to do anything with an invalid tree anyway, so...
I mean, it could do things. You could skip invalid nodes. It doesn't need to generate anything invalid in an import.
Like, if you're generating documentation, you can require that the code be well formed.
You could
say,
yeah.
If you're generating documentation for code that doesn't even compile,
it's not good. I'm just saying.
You're just doing nonsense. Honestly, like.
It would probably want the semantic nodes anyway, and those aren't going to have the trivia, so I'll have to... I don't know. I have no idea. Because the documentation generator is going to want semantic nodes, not syntax nodes. And the syntax nodes currently are where all this is, so the semantic nodes may also just have all the tokens, if that's what I'm going for.
If you're doing that, then I'd just collect comments before. Like, literally, when you create a declaration, a function declaration, you grab the first token that's part of it, and check if that has a leading comment, and you attach it, and that's it.
Mm-hmm.
Like, if anyone expects, I don't know, a random comment after the opening brace to be added to the documentation, then I'm sorry, but what the hell are you doing?
No, it's not going to be every token that's relevant.
For the function.
Alrighty, I've got some refactoring to do that I definitely don't want to do on stream, and I don't think I've got anything else I want to do right now, so I'll probably take a break, do lunch, refactor off camera, and come back eventually. I might be busy over the weekend, we'll see. Alright, as always, thanks for your help. I'm gonna go relax.
No problem.